Hi, welcome back to another episode of Algebra in Words, the video series. In this video, we're continuing on from our discussion on quadratic equations, and in this video, we're going to look at quadratic inequalities. Now, if you saw my video on absolute value inequalities, where we did the test method, the test point method, this method that we're going to do here is very similar almost to the T. So if you want another example and more background to review that, you can go back to that video. Also, if you prefer to follow along with the written steps, I have them written in my book Algebra in Words 2, starting on page 104. And the link to that on Amazon is in the description box below. But let's get started. So first of all, what is a quadratic inequality? Well, a quadratic inequality is looking at the domain, or all the possible x values, given certain conditions. And normally, and I have an example equation here, there's a greater than or less than, or an inequality symbol, and the inequality symbol tells you whether you're supposed to report values that are above or below the line represented by whatever this is. In this case, it's 0, but it could be any number. I'm going to walk you through the steps on how we're going to do it, and then we're going to do it. But I also have a graphical representation of the representative graph of this equation, and also what the inequality means. So first of all, I have this equation graphed as the parabola that it would be. And I already know what the x-intercept would be if we solved it. It would be -2 and 9. And so I have them plotted, and also we know that the y-intercept would be -18, which would be somewhere down there, and the parabola opens upward. So this is a basic sketch. But next I want to focus on what are we looking at greater than or less than? We're looking at greater than or less than 0. What is 0? 0 actually means the equation y equals 0. And normally we would know that as the x-axis, but just to extra highlight it, I just drew an extra red dotted line over it, just to show that we're kind of focusing at above or below that line. So since this is less than, then what this question is really asking is, what are the x values of the parabola less than or under that line of x equals 0? Y equals 0, the horizontal line. So in short, we would want to say whatever these x values underneath would be. Or if it hypothetically said greater than 0, then it would be asking us what all the possible x values of these portions of the parabola would be above the line. Now a good starting point is something that we already know. Suppose this were equals. If it were equals, it'd be a quadratic equation. We would solve that. The solution would be the x-intercepts, which we already have. And then the answers would be those points. But when it's greater than or less than, it's asking us the x values either above the line or below the line. So with the method that I'm going to do with you next, that'll help us answer that. So here's the steps that we're going to use. First, we're going to take our inequality and set it equal to 0, like it's an equation. Then we're going to solve to get the x-intercepts. If we can solve that by factoring and solving, that would be the quickest way. I recommend doing that. But if we can't do that, then I would go right to using the quadratic formula, as I discussed in the previous video, and then that'll give you your 2x intercepts. From there, those x-intercepts we then want to call boundary points. We would plot them on a regular number line. Then we would define each of the 3 regions, the left region, the middle region, and the right region. And then in each of those regions, you would choose a test point. Remember that you can choose any test point. Try to choose an easy test point like 0 or 1 or -1 if possible. But remember that you cannot choose a test point that's the same as a boundary point, because then that's not a test point. You do the test point by taking the number and substituting it back into the original inequality, simplifying, and see if the statement comes out true or false. If the statement comes out true, then you keep the region that that test point represented as part of your solution. And if your test point comes out to a false statement, then you reject the region from that respective test point. So anyway, let's get started. So first we have x squared minus 7x minus 18 is less than 0. If we made that an equation, by setting it equal to 0, and then solving, we could solve this by factoring into x minus 9 and x plus 2. Set each binomial equal to 0, and we should already know how to do that, so I'm going to jump right to what they equal. X would equal 9, and x would equal negative 2. So we have 9 and negative 2. Normally we would call these our solutions, but this is for an inequality, so now these are our boundary points, and we're going to plot them on a basic number line. And plot the smaller one on the left, so negative 2 here, and 9 to the right. And these are our boundary points. So we have 3 regions. The left region, the middle region, and the right region. And now let's use interval notation to define each region, starting with the left. The left one would be negative infinity with a parenthesis, comma, negative 2. And will this end with a parenthesis or a bracket? Well, since this is less than only, then this would be non-inclusive, and we're going to put a parenthesis for that. And if you need a refresher on whether to use a parenthesis or bracket and inclusive and non-inclusive inequalities, please go back to my previous video on inequalities, and I go through all that. The middle region will be parenthesis negative 2, comma, 9, ending in parenthesis. And then the right region will be 9, comma, infinity, parenthesis. Okay, and now let's choose a test point for each region. Try to choose the easiest numbers if possible. So starting on the left, let's choose negative 3. In the middle, I always recommend 0 if you can use 0, and we can use 0 here. And then for the test point on the right, let's use 10. Just remember, you cannot use the same number of a boundary point as a test point. Okay, now we're going to take each of the test points and substitute them into the original inequality and test it for accuracy, or for the truth of the statement. So starting with negative 3, I substituted negative 3 in for x in x squared, and x next to the 7x, into the 7x. And now let's simplify. Negative 3 squared is 9. Negative 7 times negative 3 is 21. And minus 18 is less than 0. Okay? So then if we do 21 minus 18, we get 3. And 9 plus 3 is 12. And is this statement true or false? 12 is less than 0. It's false. So what does false mean? It means we reject the region of the test point. So what I like to do is to just put a cross through that interval notation representing that region. Okay, and now let's do it again for test point 0. 0 in for x squared minus 7 times 0 minus 18 is less than 0. 0 squared is 0. Negative 7 times 0 is 0, leaving just negative 18 is less than 0. And that's a question mark. Is negative 18 less than 0? Yes, that's a true statement. So let's say true. True means keep that region. So I circled it. And now we're going to test 10. And let's see if we can squeeze it in here. Ten squared minus 7 times 10 minus 18 is less than 0. So 10 squared is 100. Negative 7 times 10 is negative 70. And minus 18. Negative 70 minus 18 is negative 88. So 100 minus 88 would be 12. And is 12 less than 0? No. False. So therefore, we would reject that region from that test point as well. So the answer is negative. The answer is in interval notation, parenthesis, negative 2, comma, 9, parenthesis. And that's it. There's not really much else to say about it. So I'm going to pause the video and put one more example up. Okay, I have one more equation on the board, an inequality. 7x squared plus 34x minus 5 is greater than or equal to 0. So we're going to go through our method again, and let's try to factor and solve. First, let's convert this to an equation to do the proper thing. So this would be 7x squared plus 34x minus 5 equals 0. And now from there we can factor and solve. And I think we can factor this into 7x 7x minus, I think, plus 1 minus 1 times x plus 5. And if we FOIL that, it will check out to the original. And now we can solve each quantity. So set this equal to 0, plus 1, and 7x equals 1. Divide both sides by coefficient 7. And we get x equals 1/7. And then for this one, if we set x plus 5 equal to 0 and solve, we get x equals to negative 5. Okay, so I'm just going to write them up here for now. That should be negative. And what we just found are our boundary points. So let me just erase this part of the board so we have room to work, and then we'll plot them on a number line. So let's draw the number line. And let's plot negative 5 on the left, and 1/7 closer to the right because it's the bigger number. And now we will, those are our boundary points, and now let's define each region. On the left, we have negative infinity, comma, negative 5. And this will end now with a bracket because the greater than or equal to is an inclusive symbol, and it's because it's got the or equal to line in the bottom. The middle region will be bracket negative 5, comma 1/7, and close bracket. And the region in the right will be defined as bracket 1/7, comma, infinity. Okay, so now we have our three boundaries defined with interval notation. Now in each boundary, choose a test point. In the left region, let's choose one lower than -5, so how about -6? And between -5 and 1/7, 0. And greater than 1/7, let's choose 1. And now we're going to take each of those test points and substitute them into the original equation and simplify and see if the statement comes out true or false. Starting with -6, and we have 7 times -6 squared plus 34 times -6 and -5 is greater than or equal to 0. I paused the video and put the numbers in and calculated them for you, and they came out to 252 minus 204 minus 5, and when you combine them you get 43 is greater than 0. You can check my math on that. Is that statement true or false? It's true. 43 is greater than or equal to 0. So that's true. And what does true mean? Keep that region from that test point, and I circled that. Okay, now let's test by putting test point 0 into the original. Alright, and 0 squared is obviously 0, 7 times 0 is 0, 34 times 0 is 0. So those terms are gone, and it leaves us with -5 is greater than or equal to 0. And is that statement true or false? It's false. What does false mean? Cross out or reject that region. And now let's test the last point, 1. So 7 times 1 squared plus 34 times 1 minus 5 is greater than or equal to 0. This becomes 7. This becomes 34. And again, minus 5. 7 times 34 gives us 41. Minus 5 is going to give us 36. And is 36 greater than or equal to 0? Yes, that's true. So what does that mean? It means we keep this region as part of the answer. So the way that we want to officially report this is rewrite, and sorry, this should be a parenthesis. There should always be a parenthesis by an infinity or negative infinity. So the answer is going to be parenthesis, negative infinity, comma, -5, bracket, and now we're going to put the union symbol, and then bracket, 1/7, comma, infinity, parenthesis. And that is our solution for finding the domain of a quadratic inequality. And before I end the video, if you just want to think about this conceptually for a second, you can probably visualize that this region and this region are probably from the part of the parabola that are like this above the line, as opposed to the little U-shaped part where that part would have been here and that part is rejected. So that's pretty much all there is to say about quadratic inequalities. Thanks for watching, and I hope you found this informative, and I'll see you in the next video.